Good afternoon. Welcome to the first live edition of WeatherWise. Today, we're going to focus on that major winter storm that impacted Arkansas just over the weekend. We'll go into details on how things unfolded and also talk about some forecasting signs behind this storm. Why was it such a wide range and who got freezing rain versus sleet? Why did we get so much sleet in Arkansas? Meanwhile, in North Arkansas, they're saying we missed out on some snow that was in the forecast. So let's talk about what unfolded throughout Friday into the weekend. And here's what it looked like on the radar satellite view with the moisture moving in. Noon on Friday, the temperature was 39 degrees. We were telling you that Arctic air was spilling its way in from the northeast. Now, fascinating thing about Arctic air is it's shallow and it's heavy. That's because cold air is heavier than warm air due to the molecules within the air mass are closely together, and that produces more weight within the atmosphere. So with this shallow air mass, cold air mass making its way in from the northeast, it has to go around the Ozarks. You see the temperature, 28 in Oklahoma City, 39 in Little Rock, 35 in Memphis, and 25 in Paducah. So this cold Arctic air had to go around the Ozarks and spill its way on the backside of Little Rock or backside of Arkansas, and then also bled its way down into the river valley of Texas. Watch what happens here as we advance this past radar satellite data. So there you see the temperatures are going down. We certainly felt that Arctic air once we got into Friday afternoon and Friday evening. The temperatures, 6 o'clock, they drop below freezing at Little Rock. And look at it, 19 in Branson, 16 in Paducah, 27 in Wichita Falls. They start to see some sleet and freezing rain, but it was still into the 40s in Texarkana. But the moisture moved in a little sooner than expected when the newer models came out Friday afternoon. It was about an hour or 2 hours earlier than what was anticipated. 6:30 Friday evening, we had moisture moving into southwest Arkansas, and we were getting reports of some freezing rain and sleet happening into southwest Arkansas. So 29 is where we were, 8:30 in the evening, snow breaking out through Oklahoma City. What's going on here is we've got that Arctic air that's creating a wedge in the atmosphere. So you think about this wedge of Arctic air pushing the warmer air that's moving in here from the southwest aloft. That's creating lift, and that's why we have this shield of different types of precipitation. It's known technical term as isentropic lift. And it is a tough thing to forecast sometimes, because if the Arctic air is too strong, it can be too dry, because Arctic air is usually on the dry side, and that chisels away at the northern edge of a system. Well, we went through Friday evening into Friday night. That's when things really started to pick up in coverage and intensity. I left the station here. It was sleet at 10 o'clock. Then over into Midtown, it started to change over to snow. We told you we were right on the line between heavy snow and also the potential of heavy sleet. You see that unfolding across the region. 11 o'clock, still lots of snow happening over Oklahoma. Meanwhile, they're getting freezing rain that was really causing some issues into Texarkana. The temperatures continue to drop down into the teens, but that line, the blue and pink, it did not really budge at all. That made a very tough forecast, because you had like a miniature front that was creating a lot of lift on the northern side. So that's why we had these bands of heavy snow develop, but not everybody saw the heavy snow across the region. The darker blues, the whites, showing up right across parts of Saline County and Pulaski County, and that ended up being some significant totals for some parts of the region. Meanwhile, where I live, I got about 3 inches of snow before it changed over to a sleet combination. So here's Saturday morning. Things start to wind down in parts of the region, but it was bitterly cold. 13 was the number. The wind chills, they were below zero, well below zero across the region, if I could get that out. 7 was the number in Branson, 15 in Memphis. There's the pink, still showing the potential of sleet and or freezing rain. But this is round one. So as round one made its way through, we had round two come into play, and this was the upper level dynamics part of the system. We had what's known as a shortwave trough that made its way in from Texas and Oklahoma. It used to be a upper level closed low, but then it opened up, and that provided more dynamics, more lift in the atmosphere. So as round two started to make its way in by later Saturday into Saturday evening, you see the drier air moving in here for Saturday afternoon, still some pink with some sleet for the most part, a little bit of freezing rain. They were getting some ice into Mississippi, but they really got hit with the ice with round two. And now we got the reports popping up of the snow and also the sleet around the region. So here's midnight on Sunday, 15 degrees. We've got the snow in place. There was some heavy snow in Oklahoma. However, what you're seeing here, it's not working out exactly as what the legend is showing. So this is supposed to be snow according to radar, but it was sleet. It was heavy sleet across parts of north central Arkansas. Therefore, the snow totals that we were forecasting, and pretty much everybody was forecasting, almost a foot of snow, really did not add up in that part of Arkansas just because it was sleet with the temperature profile. And I'll get more into that coming up in the next few minutes. 1:30 in the morning, 15 degrees here in Little Rock, but it shows snow, but it was definitely heavy sleet through the overnight hours that added up to several inches of sleet across the region. And then once we got into, let's kind of skip by a little bit here too fast. Once we got into Sunday morning, we started to wind things down. And then eventually it did change over to snow into more of the River Valley and also into west central Arkansas. The problem was we had storms develop as the surface low developed into Mississippi and also Alabama. That robbed a lot of the moisture of the backside of this system. So that's why you're starting to see more dry air build its way into West Arkansas. And also there was some thunder sleet and thunder freezing rain just because there was a lot of lift in this part of Arkansas, also over to Mississippi, and that's why they had just a nasty ice storm. So there's Sunday morning, 8 o'clock, things started to wind down. Yeah, there was a little shield of some snow scooting its way through northeast Oklahoma, northwest Arkansas, added up to another 1 to 2 inches, but by that time, watch what happens. The dry air moves in, and it just goes bye-bye. And then we're just left off with pretty cold conditions, temperatures into the 20s. We had some sunshine out there on Sunday, and the winter storm was really winding down other than a little disturbance to try to produce a few flurries late Sunday night, early Monday morning, but didn't amount to anything at all. So that is the recap of the entire winter storm. Now, when we look at what happened with the ice accumulation, these are all the reports of the freezing rain accretion across the region. And accretion is what we use for freezing rain because the ice collects and doesn't accumulate on objects. We had freezing rain, 1/10 of an inch close to Texarkana, almost a half-inch ice around Boston, Texas, and then also had about 1/3 of an inch of ice where the ice storm warnings were issued in Union County. But by far the worst of the ice was in Mississippi, especially Oxford. They saw 3/4 of an inch of ice to 1 inch of ice in some locations, and that built its way into the Tennessee Valley. So when we take a look at the types of winter precipitation, let me go over here because I want to talk about the snow totals as well. So we can go over to Storm Track 11 pair if we could. So here are the snow totals on Storm Track 11. And the big winner was North Little Rock. Locally, 11 inches of the combination of snow and sleet. Then those numbers started to drop off quickly once you got south of Little Rock. And you notice not too much in reports coming south of Little Rock. Not too much happening in Pine Bluff or Hot Springs. Yes, you did see a little bit of sleet and snow, but not the extent that what we saw right over parts of Pulaski County and then also over White County. We got a report here, BB, around 6.5 inches of snow and sleet. The highest total I could find was 12 in Whit Springs in north central Arkansas. Then also Mount Nebo came in with 12 inches. And they're saying it was primarily snow over Mount Nebo. In northwest Arkansas, the range was pretty much 6 to 12 inches, but it's supposed to be more. And I'll show you what the models were showing with this system and what they were forecasting for and why everybody went on the high side, because you go with the trend of the models and the models are all saying, hey, it's going to be heavy snow in that part of the state. You're not going to go against that. So more like 6 to 8, a few 9 showing up here in northeast Arkansas. Okay, let's go back to Max now, Perry. So we showed you this graphic a lot, and I'll go over it again because this is why we had different types of precipitation, due to not what was just happening temperature-wise at the surface, but it had to do with what was the temperature between 6,000 and 10,000 feet above us. So when we take a look at types of winter precipitation, the easiest case is rain. When you have temperatures above freezing from the cloud all the way down to the surface, you get raindrops. On the opposite side, when you have temperatures that are freezing or below, you have ice crystals that form into snowflakes, and they will stay in the form of snowflakes all the way down to the ground. But the two tricky cases are sleet and freezing rain. And this triangle shows that wedge of warm air, like I said, right around 6,000 to 10,000 feet. So snowflakes, in the case of sleet, they go through this layer of warm air, they melt into raindrops, and then as they go through the sub-freezing layer of air, those raindrops will freeze, become ice pellets. That's what's known as sleet. When you have a thicker layer of warm air or a thinner layer of shallow cold air that's sub-freezing, the snowflakes melt, turn into raindrops. They stay in the form of raindrops all the way down to the surface and then freeze on contact. And once they make their way onto the surface contact, they become a glaze of ice. And that's what is known as freezing rain. That's what creates all the issues with ice collecting on power lines, trees, tree branches, and just causing a lot of destruction when it comes to trees splitting and branches breaking and power lines coming down. That's been the case for friends and family over in Mississippi and also into Middle Tennessee. So as a meteorologist, we are looking what's happening in the atmosphere, and the National Weather Service all across the country pretty much launches weather balloons. I'm sure you've heard of weather balloons. They're usually launched twice a day, in the morning and also in the evening. In some special cases, when the weather is much more active and much more interesting, they'll launch it in the early afternoon hours or even late at night. So this is just one diagram from the winter storm from Little Rock on January 24th, 12 o'clock in the afternoon. That was this past Saturday. And what I want to point out is we have a red line and a green line. And Perry, you can take this full, I think. So we're looking at these two different lines. The red line is the temperature line as you go from the surface all the way up higher and higher into the atmosphere. The green line is the dew point. All you need to know about the dew point is where the red line and the green line come together. That means that the atmosphere is fully saturated, and that's where your clouds are located. The blue line that you see here, stretching from the zero and moving from the lower left all the way up to the upper right, that is the temperature line, the freezing line. And then we have the gray lines to show 10,000 feet and 5,000 feet on the side here. Okay, Perry, let's bring it back to me, please. So here is the layer that we're looking at, 10,000, 5,000 feet. So here's the surface. We were 10 degrees below zero when it comes to Celsius, because science, we use the metric system. So that's about 14 degrees when you convert it to Fahrenheit. Usually your temperature goes lower as you get higher and higher into the atmosphere. I'm sure you've been on a mountain. You notice it usually is colder on the mountains versus down in the valleys. Well, look what happens to this line. It goes cooler, but then it reverses and it goes warmer. It passes the freezing line here and it continues to warm up. So at 5,000 feet, the temperature is probably about 34, 35 degrees. And that continued to be the case all the way up until 10,000 feet. So this is your layer of warm air that we talk about when it comes to different types of precipitation, and then it cools down. So your snowflakes form in this area above 10,000 feet, but they melted, became raindrops between 10,000 and 5,000 feet, but then we have such a shallow but really intense cold layer of air right at the surface, so that's why the raindrops froze and turned into sleet. Into South Arkansas and Southeast Arkansas, your red line would be more like this, so it wouldn't be as sharp, and that's why it stayed in the form of a raindrop and turned into freezing rain. But we were watching this line continue to change. This red line continued to back more to the left-hand side because they launched another weather balloon Saturday evening, I think also later Saturday night. So by the time it was Sunday and everything started to change back over to snow, everything was behind the freezing line. So snowflakes come in different forms, and it all depends on where they develop in the temperature environment. We had a really cool phenomenon happen with snowflakes forming right at the surface because they formed below that layer of warm air on Saturday when we had that very light snow happening. And I was thinking, okay, why are we getting snow when it says we should be seeing sleet if they're going through a warm layer? Well, it just happened to be in the perfect temperature range that we had these dendrites and beautiful snowflakes form across the region. So here are different snowflakes you may not know. We are all familiar with the classic dendrite situation, but there are other snowflakes out there. So let's break it down here for you. According to the cloud temperature where these snowflakes form, thin plates 25 to 32 degrees Fahrenheit, needles 21 to 25 degrees Fahrenheit. And I've seen needles. I haven't really seen thin plates though. Hollow columns 14 to 21 degrees Fahrenheit, stellar plates 10 to 14 degrees Fahrenheit, and then dendrites 3 degrees to 10 degrees Fahrenheit. And that was the case right above the surface, about probably 1,000 feet or so, that we had the perfect zone for these dendrites to form over the weekend, and we got some really great pictures of that. But I want to show some cool, like, microscopic pictures from this website. This is snowcrystals.com on Storm Track 11, Perry, and this really showcases how many different types of snowflakes there are. I mean, this is really cool to me, just how nature can produce all this, and it's just because of how the water molecule operates when it comes together and forms a six-sided figure, that you have these 6 arms that stretch out to become dendrites. But then there's so many different ones. There's snowflakes that become triangles. I didn't even know that was a possibility. So next time it snows, I'm not saying I'm forecasting this anytime soon, but next time it snows, get something with a black background that doesn't have any fibers or anything, that's very smooth, and you can use your camera to get a really good picture of a snowflake. If you have a good camera, I shot a snowflake with my Android camera, and it did really good resolution. I was surprised what type of resolution I got. Let's talk about weather models now. Because before this storm evolved, 5 days in advance, it started to get a lot of chatter on social media, and also national weather outlets were talking about it. And they were showing models, and you may have been looking at your app, if it's the Apple app or other generic weather apps. Those apps take into account just raw data. So you're looking at raw data right here by the GFS model. I can only just show you one model, but I want to show you the progression of how this winter storm evolved on this one model and how it all changed, and that's why your forecasts also changed. We never like to put out a forecast of a winter storm or severe weather 5 days in advance because we know it's going to change. But social media people out there want to get attention and they want to get paid. It's a big talker, and you put out a picture of a snowfall map, total map, whatever, it's going to get a lot of people's attention, and the person that posted that can get paid very easily through your comments, through your likes, through your shares. So just keep that in mind. Next time you see a winter weather map or snowfall map 5, 6, 7 days in advance, check your source. If it's not a verified source, if they're not a meteorologist, or if they really don't have any weather background, look for another source. Don't interact with that page. Don't comment. Just leave it alone and move on and try to find something better. So this is the GFS. This is the model forecast for Saturday morning. This was initialized back on January 20th. And you see the blue, that's the snow. The pink, that's where you're seeing the freezing rain, and ice is the pink, and of course rain is green. So that is what was producing at that time a solid shield of some heavy snow across a large part of Arkansas, and then some ice in South Arkansas. Now we'll go to the very next day with this model produced, and this is advanced on me here, but this is what Saturday morning looked like for that. So this is January 21st initialized for Saturday morning, and now we're seeing a pretty good spot of some heavy snow right across central Arkansas. The purple, that's where the freezing rain ice is. The more freezing rain is located in the pink. Next slide, this is January 22nd. Still, our confidence in winter weather continues to go up by this time, of course. And then we're honing in on a pattern that we're going to see some heavy snowfall across central Arkansas. So those are 4 different model views within the same model as time went on to show you how things did change. And it wiggles back and forth. And there were even stronger scenarios where we had snow really expected for northwest Arkansas. I can show you that here. This is the ensemble forecast by the European. This was 6Z. So that's like midnight on January 22nd. And look, every single solution, I'm going to zoom in here because you probably can't see that. Every single solution showed there was going to be heavy snow somewhere in Arkansas, and pretty much it was going to be northwest Arkansas. And if you look at the legend here, that's well over a foot in the pink. So how many of these show that a foot of snow is definitely a good possibility? A majority of them. And that's the European, and that's usually better handling at winter storms versus the GFS. And then here's another view, more of the same. This is the European. Also showing just a band of very heavy snow across northwest Arkansas, and then a very sharp cutoff once you got into central Arkansas because it was trying to depict on where that line would be located. And there's another one. So you get the idea. So going back to the forecast that we produced, and we can go back to Max Perry, thank you. This is the forecast that we came up with looking at data, and we look at a lot of data. We don't just look at the European, we don't look at the GFS, we're looking at the future skew-Ts to try to figure out where the snow and sleet line are setting up, and it can take a few hours. I mean, it can be exhausting, believe it or not, looking at a lot of data because mentally you're trying to figure out where is everything going to set up, and you want to be right, you want to be accurate. So this is what we came up with. And overall, I think we did a good job here at THV 11. This was the final forecast before things really started to get going, and we made slight tweaks compared to the first forecast. I think they came out on Thursday. Before I had like 1 to 3, it was a little bit farther north, Trace to 1, which is a little bit further to the north as well. But overall, we said about a trace to 4 inches in large parts of central Arkansas. That was pretty close, other than we had some more snow into parts of Pulaski County. This is just the snowfall forecast now. 3 to 6 going through Searcy, Russellville, over towards Yell County. A south 6 to 12 into North Arkansas, because what I showed you there, all model information supported that case. And then even the potential, I thought there would be some bands and maybe some more dynamics to produce 10 to 15, maybe more than that, in some locations over the Ozarks, because you also have the mountains, and that can produce more lift over the region and enhance those snowfall totals, because we've seen it many times that the mountains overperform compared to what the models said. So I would say this was a miss, but overall, I would give ourselves, probably a 90% when it came to the forecast for snow. As for sleet, still not too bad. We said 2 to 4 inches of sleet. Some locations did end up with 5 to 6 inches of sleet. And when it comes to sleet, it's tough because usually 1 inch of liquid equals 1 to 2 inches of sleet. And we had a lot of moisture with this system. Of course, we said the sleet would start to really trail off the farther north you got, but the sleet really reached its way a little bit further to the north than we expected. And with more ice anticipated into southeast Arkansas, this total was probably a little bit lower, because before we were going, I think, 1/2 to 1 versus 1/2 to 2 into southeast Arkansas. Now, for the freezing rain, I think we did pretty good with that, because you looked at a lot of model information and they were just painting out a huge swath of freezing rain across the region. You may have heard, oh my gosh, it's going to be 1/2 inch to 1 inch of freezing rain, and ice is going to bring down power lines and trees all across central Arkansas. Well, that's because people were just taking the raw model data and not looking at, okay, what are the temperatures at 5,000 feet? What are the temperatures at 2,500 feet? Because models aren't perfect. They are guidance. So we took that guidance into account. We looked at more information and we said, okay, the best chance of really a lot of freezing rain would be for southeast Arkansas. And that was the case. What we did miss was that first round produced more freezing rain into extreme southwest Arkansas than what was expected. About a 1/10 to 1/4 was anticipated into this part of the state that I showed you earlier. So overall, the ice forecast was not too bad. So overall, I would say we did a pretty good job with this forecast. Winter weather is always very challenging. It takes many hours, and you are looking at each and every model that comes out, and the models that come out in the morning and the evening are much more reliable than what comes out in the middle of the day or the middle of the night. And sometimes those are the ones that get a lot of social media attention, even though they don't take into as much information and really good data versus the earlier models. So with that said, things are starting to go in a better direction. The winter storm has left, so we'll just do a quick little brief forecast here. 89 hours we have spent below freezing since 6 o'clock Friday evening. We climbed above freezing at noon today. That pales in comparison to what we saw. Remember, when we got over 20 inches of snow February 2021, we spent 192 hours that were below freezing. The big problem that we're going to be concerned about over the next several nights is going to be as the slush starts to melt, and it's going to take a while for the ice to melt because ice usually takes a longer period versus snow. As this all melts through the afternoon, watch out, 7, 8 o'clock, temperatures drop below freezing, it becomes solid ice. So watch out walking around in parking lots, watch out for driving, especially along the shoulders, bottom of hills, because anywhere that runoff from melting occurs, that's where it's going to be a problem with refreezing black ice and could cause some big issues. And that will be a threat all the way into the weekend and early next week. As for the roads, we're seeing some really good improvements. The interstates are in good shape. You've got plenty of lanes open. Just watch out for those on and off ramps. The main highways, there's going to be some patches of slush that will turn into solid ice through the overnight and pretty much each night and through the morning hours. So be careful on that as you head back to work throughout the rest of the week. And then those side streets, back roads, untreated roads, those are going to be a problem because they are not seeing too much in the form of melting. So expect those to remain snow and ice covered, even though temperatures will climb above freezing for tomorrow and also into Thursday. Those back roads will still be quite dicey, especially on the hills throughout the region. Well, with that said, thank you for tuning into WeatherWise. Thank you for all of your pictures that you sent into the THV11 Weather Impact team. It really tells the story. And if you've got pictures, doesn't always have to be pictures of weather. It could be sunsets, sunrises, anything nature. We love to see it. 501-376-1111. And if you have any ideas for any episodes of Weatherwise, I want to hear them. You can direct message me on my Facebook page, or you can contact me on my email, nscott@thv11.com. Have a great day, and I'll see you soon. Thanks for watching. I'm meteorologist Nathan Scott.